Hi, everybody. Professor Monty here, and let's answer the question, what is elasticity? Well, elasticity essentially is just this. It's the ratio percent change in quantity divided by the percent change in price. And so if we get a number such as the elasticity is 0.3, well, we can think of it this way, which means if the price goes up 1%, then the quantity actually goes down 0.3 or 0.3%. And we'll see why those go in different directions, even though we're showing this as a positive number. And that's because how we're going to deal with what the formula is. Okay, but that's essentially what it is. It's just how does the quantity change when we change the price? So if I look at it, just the change in price as being a 1 or a 1% change, then it says, okay, if I change the price 1%, how does quantity change? Oh, 0.3%. Or if this is a 1.7, 1.7%. But remember, from economics, price and quantity always go in opposite directions. So when price goes up, we demand more. When price goes down, we demand more. Okay, so opposite directions. So let's take this idea, and if you want to see where the formula comes from, I'll show you that. If you just wanted to know the idea of what it means, we're actually done, but I'm going to keep going, and we're going to show where this formula comes from. So let's say this, percent change in quantity. So we're saying the change in quantity over what the original quantity was. The change in price over what the original price was. Now, we're going to use quantity as the demand function based on whatever the price is. So this Q is actually going to change. Let's say this. We know dQ over Q times P over the change in P. We can rewrite it this way, invert and multiply the denominator when we have this complex fraction. Well, let's rearrange things. Let's go P over Q times the change in quantity over the change in price. Now remember, I said this quantity is a function of price. So we're going to change that to D of P, the demand at a certain price. Okay, that's the quantity. So taking all this, now there's something else that comes into play. In calculus, we know that this dq dp, or delta q over delta p, as delta p goes to 0, so when our change in price is getting smaller and smaller, this thing actually goes to dq dp. It's actually the derivative. So this piece, as delta p goes to 0, goes to dp dq. dq dp. Price is still price. Quantity is this dp. It's the demand function. Well, that's essentially what we're doing here. Let me go one step more, because dq dp, the change in quantity with respect to price, well, that's the derivative of the demand function. This piece is d prime of p. And so if we put all that together, what we end up with is my elasticity, we'll call it E of P, P being the price, is P times D prime of P all over the original demand function D of P. That's our formula. That's literally what the percent change in quantity or percent change in price gives us. Now, here's where it gets a little bit weird. P is price, it's always positive. dP is quantity, it's always positive. At least non-negative for both of those. D prime of P is the rate of change of quantity demanded when we change price. Remember, we said when price goes up, quantity goes down. When price goes down, quantity goes up. Those go in opposite directions. So this D prime of P is always negative. Well, if these are both positive and that one's negative, the sign of this is always negative. In math, a lot of times we don't want that to be negative because then we have to worry about absolute values and things like that. So what they'll often do is they'll put a negative right here. Maybe they'll put it in front of the fraction. We'll just put it up there to make it easy. But that's usually what they use as your formula for elasticity. Price times the derivative of demand over the original demand function. Change the sign. Now this negative here is always going to cancel out with your d prime of p because that's always going to be negative. So do be careful about that. If you get a negative answer and that didn't cancel out, you did not do it correctly. So do be careful about that. This always comes out as a positive number since we changed the sign right there. And again, what does it mean? Well, for example, if I get E of 10 is 1.7, that means when the price is $10, this is telling us the percent change in quantity over the percent change in price. In other words, quantity will have, remember, we can think of that as over 1. So that's going to be the percent change in quantity is 1.7 when the percent change in price is 1. So if this is 1%, this is 1.7%. That would say, oh, we're elastic. Elastic's anytime we're over 1. But remember, these are going in opposite directions. If price goes up 1%, quantity demanded is going to go down about 1.7%. It's elastic. And we have this. If E of P is greater than 1, we're elastic. If E of P is less than 1, we're inelastic. And if E of P equals 1, we're at unit elasticity. And that's actually where revenue is maximized. All right, so I had a really messy board here, but we tried to prove this. This is the key, is what's the formula. So if we're doing the demand function in terms of the price, this is what the formula looks like. The other idea is, oh, what does it mean? What's the percent change in quantity over the percent change in price? So something like this. Well, if I get 1.7 at $10 and I increase the price a little bit, say 1% from $10. Well, if price changes by 1%, quantity is going to change about 1.7%, but in the opposite direction. Okay, so that's it. That's the idea of it. It's a little technical. Do look at my other video. I'll put a link to it that is working out a problem with elasticity and talking about whether it's elastic or inelastic and what that means. All right, if you like this, as always, please do subscribe to my channel. Click on like the video so other people can find it. But other than that, we will talk more later.